In this video, we are going to discuss how to find the equation of a polynomial function given its graph. And in particular, in this case, we are going to try to find the polynomial function that has the smallest degree possible. Let's go ahead and get started. First, you want to identify all of the zeros. So we've got a 0 right here, we've got a 0 right here, and we've got a 0 right here. So this happens at -1, +1, and 4. Those are my zeros. Once you've found those zeros, you want to decide, does the graph cross the x-axis at that 0, or does it just touch it? So look at this first example. Here, my graph does not actually cross. It goes up to that point, touches, and then turns back around. So we say that this one, that the graph touches at -1. Look at the other two x-intercepts. In both cases, here and here, the graph actually crosses. And again, notice if I'm going from the left to right, there I crossed the x-axis at +1. Going from left to right, I cross the x-axis at +4. So let's list our zeros with their multiplicity. First, we'll start with -1. So -1 is a 0, and what multiplicity do we want to give it? Since it touches the x-axis and does not cross it, it must have an even multiplicity. Now, since we want to use the smallest degree possible, we want to keep our exponent as low as possible. So we're going to use the smallest positive even number for our multiplicity, which is 2. Our next 0 is 1, and it crosses the x-axis, which means that its multiplicity is odd. Again, since we want to use the smallest degree possible for our polynomial function, we are going to use the smallest possible odd number that is positive, so our multiplicity will be 1. Similarly, at 4, it crosses the x-axis, and so that means it has odd multiplicity, and we will use the smallest odd number, which is 1, the smallest positive odd number. Once we have identified all of the zeros, we are going to be able to write this polynomial in factored form. However, one thing you always need to do is start with the lead coefficient of a, which at the current time we do not know what it is. So start with a times, and then looking at this first 0, my 0 is -1, and it has multiplicity 2. Since the 0 is -1, that means my factor will be x plus 1, and that multiplicity of 2 tells me that my exponent will be 2 on this factor. Looking at my next 0, the 0 is actually 1, and the multiplicity is 1. Since the 0 is equal to +1, that means that my factor will be x minus 1. And since the multiplicity is 1, that means that my exponent would be 1. Now, as a general rule, we never write 1 as an exponent, and we just keep it blank. All right. Similarly, the last factor will have to be, since our 0 is +4, our last factor is x minus 4. And again, since the multiplicity is 1, that means that our exponent will be equal to 1, and we aren't going to write 1 down. All right, so we are very close to having an equation. The only issue is we don't know what a should be. Sometimes, or in this case, they give us a point, And that tells us that we can find the exact a. So since we have this point, we know that when x is equal to 3, f of x is equal to 8. And so what we're going to do is actually plug in for f of x and for x, and then we're going to solve for a. So let's start by plugging in for f of x is equal to 8. So I'm going to replace f of x with 8. I'm going to bring down the a, and then everywhere I see an x, I'm going to replace it with 3. And so I plug in x equals 3, and I fill out the rest of my equation. All right. So next, 3 plus 1 is 4, so this will be 4 squared. 3 minus 1 is 2, and 3 minus 4 is negative 1. Multiplying this out, we end up getting 32. Right, 4 squared is 16, times 2 is 32. Oh, it's going to be times negative 1 is negative 32. A. And next, I just divide both sides by negative 32. And I end up getting a, these cancel out, I end up getting a equals negative 8 divided by 32, which simplifies if I divide top and bottom by 8, that'll simplify to negative 1/4. And so now we have our final solution. F of x is equal to negative 1/4 x plus 1 squared, x minus 1, x minus 4. And that just came from up here. And I replaced the a with what it is equal to, which is negative 1/4. All right. Now, with a problem like this, we should check our work. And in fact, I made an earlier video with this problem, and I realized I made a couple errors because I plugged in this function into Desmos, and again, my graph did not match everything that it was supposed to match. In particular, for whatever reason, I mistakenly thought that this middle x-intercept was 2, and so I had to start from scratch. And that will happen. You aren't going to get every math problem right the first time. And that's why it is important to always check your work. So let's go ahead and do that. So I'm going to go to Desmos, and I'm going to plug in negative 1/4. And I believe it was x plus 1 squared, x minus 1, x minus 4. All right, so that's what we have for our solution. And let's see if all the points that we want to be there are there. So we're going to check all 3 x-intercepts. The x-intercepts are negative 1, 1, and 4. That's exactly what we want. What about the point up here? That is 3, 8. That works. And notice that on the left and the right of our graph, it goes to negative infinity, and that's exactly what happens here. Okay. So it is looking very good. We did this problem correctly, and that is it. So I hope that was helpful. If you have a graph of a polynomial, remember, just start by finding all of the x-intercepts, aka the zeros, and find your equation in factored form. And if you are given a point on the graph besides one of the x-intercepts, you can use that to solve for the lead coefficient of that polynomial, aka in this case we called that lead coefficient a. Hope that was helpful, and we will see you in the next video.